Hello YouTube! Today we have to repair a Horwin EK3 electric scooter. This particular vehicle is almost new, and it has passed only 1500 kilometers. The problem is that everything works fine, except the motor. It won't turn at all. I notice orange light with the check engine signal lights on the screen, which means that most probably there is a problem with the controller. Also, I notice that while the scooter is rolling, it has a resistance on movement. This can be only due to two reasons. One reason is shorted motor windings, or second reason, which is shorted MOSFET on the controller. Now let's make a diagnosis to see exactly where the problem is. The first thing we do is to remove the vehicle's battery. Then we disconnect the controller's communication plug, Hall sensor plug, and finally the three-phase wire that go to the hub motor. Once we remove the wiring, we will need to get a multimeter. On the multimeter, the selector must go to the continuity option. And then we measure all phases separately with the positive and negative poles of the controller. Remember that to find the problematic MOSFET, the multimeter must show very low resistance, like this one, which is on yellow phase, where the resistance is almost zero. Here we are absolutely sure that there is a problem with the MOSFET of the yellow phase terminal, so we will not need to check the motor windings. Now that we have found the problem, we will proceed to the next step. Unscrew the controller from the scooter and take it to the workbench for repair. Now about the controller. It is from Lingbo Electronics, one of the best companies in China, that produces controllers for most scooters out there. It is a programmable FOC controller, sine wave at 45 amps input from battery and 150 amp output on the phases, with possibility of flux weakening. As you can see from the specification, nothing is missing from this particular controller. It is one of the best controllers companies out there. Now someone will ask me, since it is from the best companies, why did it break? To tell you truth, I don't know, but I imagine that it must have been problematic from the factory. I personally have not yet received such a controller for repair. It is the first one that came to my workbench. As you can see, each phase consists of 4 MOSFETs. So we will again take the multimeter on the continuity position and measure the terminals of each MOSFET. On the circuit we see that 2 of our 4 MOSFETs are fully shorted. Be careful, this does not mean that both of them are shorted. As you can see, in the circuit these 2 MOSFETs are in parallel connected. If one of 2 is shorted, the other one will also show a short. So don't rush to take them both out at the same time. Take off one first, check it, and if it's not good, check the other MOSFET from the circuit. After a quick research on the internet, I found the specification for this MOSFET. And as we see that this one works at 100 volts and 120 amps rated current. The ones who are interesting from the list are 5 things. The first is drain source voltage, which is at 100 volts. The second is continuous drain current at 25 degrees, which is 120 amps. The third is pulse drain current, which is at 480 amps. The fourth is the gate source voltage, which is plus minus 20 volts. And the fifth and last is the dissipation, which is at 227 watts. Very important before you start, you need to know, when you remove the MOSFETs you have to be very careful. Don't pull them with force. If you look carefully, there are very thin lines that leave the pins. They can be cut easily. So when you remove them, make sure to hit the board well, so that the MOSFET falls down by itself. When the first MOSFET comes out, we should check the terminals with the multimeter on the continuity selector switch. This particular MOSFET, as you can see, has shorted pins, so it's going to be replaced. After that, we measure the other parallel MOSFET which is on the board. As you can see, there is absolutely no short circuit. So we know that the specific MOSFET is functional and we will not need to replace it. Also, it will be good to confirm the resistance of the specific MOSFET with the others, to see that it has not been affected by the problematic neighbor. As you can see, the indications are almost the same, so we are 100% sure that the specific MOSFET will work normally. Now it is time to find the same MOSFET. Here I have 2 options. Or I will order the same and wait 2 weeks, or I will search for similar one in older controllers. As you can understand, I will choose the second option, because this video should be closed soon. I already found a similar one that is from rental scooter. After some searching, I have found the specification of the new MOSFET. As you can see, this particular one also works at 100 volts and 135 amps rated. That is 15 amps more powerful from the factory MOSFET. Gate source voltage is the same at plus minus 20 volts, pulse drain current is at 500 amps and max power dissipation is at 220 watts. Another important point is, after the repair, once you put the board back to the controller aluminum case and clamp the MOSFETs on the heatsink, do not forget to measure the continuity between MOSFETs and heatsink to make sure no MOSFET is shorting to the aluminum case or to each other.